Hello students, Mr. Madison here with my second attempt at a video instruction. I'm hopeful that the first one met with your approval and that it was somewhat helpful for you. This second video that I'm going to try to do for you has as its objective to teach you about something called a sign line, which is a technique, technique for determining when an expression is positive and when it's negative. So we're going to solve inequalities. We're going to solve inequalities by using a sign line. So this is the objective right here. When we're done with this, everybody will know how to use a sign line. A quick review: when you solve an inequality, you're going to express your answer in interval notation. So I'm going to run through very quickly what we learned about expressing solution sets using interval notation. Let's suppose you solve an equality and you end up having x is greater than 10. In interval notation, that would be parentheses, 10 to infinity, close parenthesis. Now, if this had been x is greater than or equal to 10, then we're going to do this square bracket here. Be aware that the parenthesis is an exclusionary type symbol, while the square bracket is an inclusion type symbol. In other words, with the square bracket, you're saying that number 10, which is at sort of the end point of the interval, is part of the set, part of the solution. And we did that a lot when we were discussing the domain and the range for our trig functions, but I just wanted to remind you of that. And then, of course, if you have x is, say, less than 6, we're going to go parentheses, negative infinity to 6, parenthesis. If it's x is less than or equal to 6, then we would go from negative infinity, and we want to include 6 by putting the square bracket. Sometimes you have a compound inequality. This would be a compound inequality. Let's suppose you say x is less than 8, or x is greater than or equal to 12. So in interval notation, that's going to be negative infinity to 8, parentheses, because it's just less than, in union with square bracket 12 to infinity. And this is one more compound inequality. Let's suppose you have something like negative 10 is less than or equal to x, which is less than or equal to 2. So this would be all the values between negative 10 and 2 in interval notation. That would be square bracket, because it's or equal to there, negative 10 to 2, parentheses, because that's just a less than. So that's a quick rundown on interval notation. If you have a first degree inequality, let's say something like 5x plus 12 is greater than 2. You would solve this just by using your actually properties of inequality at this time. Do whatever you typically do to isolate the x. So I'd subtract 12. 5x is greater than negative 10. Come back, divide by 5, and I'd have x is greater than negative 2. And then in interval notation, that would be parentheses, negative 2 to infinity. Another problem. Let's suppose we have 8x plus 13 is less than or equal to 10x minus 1. So if I subtract 10x from both sides, I'd have negative 2x here. If I subtract 13 from both sides, I'd have negative 14 here. the next step algebraically, of course, is to divide both sides by -2, which gives you x, which gives you 7. But please be reminded, when you divide by a negative in your efforts to isolate this variable, you have to reverse the inequality. Now, that's something you probably learned in 7th grade math or 8th grade algebra 1, but no matter how sophisticated you become in your math career, it's easy to forget that. So remember, in this situation, when you divide by a negative, make sure you reverse the inequality. And then in interval notation, this would be square bracket 7 to infinity. Let me do a compound inequality for you. -31 less than 6x minus 7 less than or equal to 11. So this compound inequality has 3 parts, part on the left, part on the right, and a part in the middle. And when you're solving this, just whatever you do to all 3 parts. So if I add 7, I got to add 7 to all 3 parts. That'd give me -24 is less than 6x is less than or equal to 18. Come back and divide by 6, again on all 3 parts. That gives you -4 is less than x, which is less than or equal to 3. This would be parentheses because it's less than -4, and then a 3 with a square bracket because it's less than or equal to. And that would be the interval for this equation, for this inequality. All right, look at this situation. X squared, this is the first time we've had a second degree expression here, is greater than or equal to 0. Well, think about that for a second. No matter what number you put in here for x, when you square it, it's either going to be positive or it's going to be 0, but it's never going to be negative. So the solution here, what values of x would cause this to be greater than 0, is going to be all real numbers. -infinity to infinity. By the way, most of the time, when we're going to be doing this in just a moment, when we're using sign lines to solve our inequalities, we're always going to have a 0 there. It's going to be greater than 0 or less than 0, and that's what we're going to be solving for. And the sign part of it refers to either positive or negative. So this is asking you, basically, the question is, when is x squared positive? When is x squared positive or 0? And the answer would be all the time, all real numbers. But look at this. Let me adjust this a little bit. What if I do this? What if I say x squared is just greater than 0? Well, x squared is always greater than 0, except for one situation, and that's when you put 0 in for x. If you put 0 in for x here, it equals 0. So it's going to be the same answer that we had up here, with the exclusion of, or to the exception of 0. So we're going to say the solution set in interval notation would be -infinity to 0, parenthesis, that excludes the 0, in union with parenthesis 0 to infinity. What if I do this? X squared is less than or equal to 0. X squared is less than or equal to 0. Well, x squared can never be less than 0 because it's always positive. But it can equal 0. But it only equals 0 once, and that's when x is 0. So kind of a strange answer here. You're going to have an interval that goes from 0 to 0, and that's your answer with square brackets. And then let's finish this little series off here. If I just say x squared is less than 0, it's never less than 0. So you would write down for your answer, empty set. There's no solutions there. No solutions at all. All right, let's move on. We're gonna do a little binomial situation here. Let's suppose you have this binomial. You have x minus 3 times x plus 10. And as I said earlier, it's either going to be less than 0 or greater than 0. So let's just say is greater than 0. And you have to solve this. All right, I want you to think about a couple things here. You have two things being multiplied. Think of this first binomial as just one factor and the second binomial as another factor. Here's what you know. You know that if you multiply a positive and a positive, you're going to get a positive. You know that if you multiply a negative and a negative, you're going to get a positive. And you know that if you multiply a positive times a negative, or a negative times a positive, you're going to get a negative. Keep that in mind. Keep this in mind as we go to solve this. So when you have a problem like this, my suggestion to you is that you solve that problem by making what I call a sign line. So a sign line is nothing but a number line. So here's the number line. And on the number line, for all these problems, you're going to place your critical values. The critical values are any value of x that would cause the expression to equal 0 or be undefined. Critical values, values of x that cause the expression to equal 0 or be undefined. In this problem, the values of x that would cause this to equal 0 would be 3 and negative 10. So I'm going to put those values on my sign line. Right above each of those critical values, I'm going to put what the value of the expression would be should I put those values into the expression. In other words, if I put negative 10 in right here, this whole thing is going to equal 0. So I make a note of that by putting a 0 there. If I put 3 in, this whole thing is going to equal 0, so I put a 0 there. All right. Now, when I put those two critical values on this sign line, I divide the line, the number line, up into 3 intervals. Here I have values of x that would be less than negative 10. In here I have values of x that would be between negative 10 and 3. And over here I have values of x that would be greater than 3. So here's what I'm going to do. I'm going to start on the left interval. I don't have to start on the left. It's just my habit of doing that. I'm going to start in the left interval, and I'm going to pick a value, any value at all, that's in that interval. And what I suggest is that you pick an exaggerated value. So I'm going to pick this number right here, which is negative 1 million. Negative 1 million. And I'm going to look up here. I'm going to ask myself, what's happening to this expression if I put negative 1 million in for x? So if I put negative 1 million right there for x, I'd have negative 1 million minus 3 would be negative 1,000,003. But the point is it would be negative. And if I put negative 1,000,000 right here for x and I add 10, it's still going to be negative. And the point is that if I choose a value from this interval and I plug it in for x, the result would be that I'd be multiplying a negative times a negative, which would give me a positive. So I'm going to indicate that by just putting a plus here over that interval. Now I'm going to pick a value from this middle interval, something between negative 10 and 3. Usually, pick 0. 0 is the easiest one to pick. And I'm going to take 0 and I'm going to put it right here. If I put 0 right there for x, 0 minus 3 would be negative. But if I put 0 there for x and add 10, I'm going to get positive. So a negative times a positive is going to give me a negative. Then I'm going to pick a number from this interval, like maybe the number 1 billion. If I pick a number from this interval, like 1 billion, and I put it in here for x, then x minus 3 would be positive, x plus 10 would be positive, and a positive times a positive is a positive. Okay, let's pause for a moment. Let me point something out to you. The vast majority of the time, as you move across your sign line from interval to interval, the sign of your answer is just going to alternate. What I mean is, If you start off with a positive here, then this will be negative and this will be positive. If you start off with a negative here, then this would be positive and this would be negative. So you don't necessarily have to pick a number from each interval. You'll catch on to the fact that as you move across your sine line from interval to interval, you just alternate between positive and negative, but not all the time, the vast majority of the time. And I'll give you an example of when it does not alternate, and I'll tell you what to look for so you'll know when that happens. But that'll be a unique situation. So here we go. Let's finish this out. This is asking you, this original problem right here is asking you, what values of x would cause x minus 3 times x plus 10 to be positive? Greater than 0 corresponds to being positive. You need to understand that. So if you look at your sine line, it would be all of these values here in union with all of these values here. And you'll notice I put a parenthesis there because it's just greater than. So when I write this in interval notation, it pretty much directly transfers from my sine line. I'm going to have negative infinity to negative 10, parenthesis, union, parenthesis, 3 to infinity. Let's do another example. What I'm trying to determine here is what values of x will cause this entire expression to be negative or 0. Less than or equal to 0 corresponds to either being negative or 0. All right. Game plan. I'm going to make a sine line. On the sine line, I'm going to put my critical values. My critical values would be the values of x that would cause the expression to be either equal to 0 or undefined. If I put a negative 20 in for x here, this whole thing would equal 0. If I put a 6 in for x, this whole thing would be undefined. So my two critical values are negative 20 and positive 6. The negative 20 causes this to equal 0, so I'm going to indicate that by putting a 0 there. The 6 causes this to be undefined, and I'm going to indicate that. And I highly encourage you to do the same. On your sine line, put the 0 there, put the undefined there. Even after you become very experienced at this and you kind of can do this when you're half asleep, I recommend you do that. I think that's going to save you at some point in time if you just pay attention to that detail. Okay, now remember, we ran through this situation when something's positive and when something's negative. I could go right through here and I could change all of these little dots that mean times. I could change them all to divide. Okay, so the fact that we have a fraction here and this fraction bar represents division doesn't matter. It doesn't matter at all. A positive divided by a positive is a positive. A positive divided by a negative is a negative, etc. So here we go. I'm going to pick a value from this interval, like negative 1,000,000. If I put negative 1,000,000 in the numerator would be negative. If I put negative 1,000,000 in the denominator for x, the denominator would be negative. And a negative divided by a negative is a positive. And then as I indicated to you before, as you move across your sine line, your sign is just going to alternate from interval to interval. So this would be negative and this would be positive. All right, so let's get our answer. We're interested in when this thing is negative or equal to 0. But I want to make this point right now. 6, the value 6, can't be part of any answer. 6 would cause this expression to be undefined. So no matter what, don't include 6 in your answer. So here we go. It's negative from here to here. It's 0 here, so I'm going to put a square bracket. I have to put a parenthesis here because at 6, the expression's undefined. So in interval notation, my solution set would be square bracket, -20 to 6, parenthesis. Let's do another one. Here I have 3 factors, which means I'm going to have 3 critical points. Here's my sign line. I ask myself what values of x would cause this expression to equal 0, -5, 12, and 20. For each of those values, this expression would equal 0. I put the little 0 there. I'm going to pick a value from this interval, the leftmost interval. I'm going to pick -1,000,000. If I put -1,000,000 right there, this binomial would be negative. If I put -1,000,000 right there, this binomial would be negative. If I put -1,000,000 right there, this binomial would be negative. So any value I pick from this interval would result in me multiplying a negative times a negative times a negative, which is negative. And then as I move across the sign line from interval to interval, my sign is going to alternate. I'm interested in when it's negative or 0. So that's going to be this leftmost interval here, and I'm going to include the -5, and it would be the interval from 12 to 20, and I'm going to include those 2 endpoints. So in interval notation, I would have -∞ to -5, square bracket, because it's or equal to, in union with, square bracket, 12 to 20. Now, if you're thinking that I'm just kind of overemphasizing the square bracket parenthesis thing and when to use those, I can tell you that the number one reason students get answers wrong when they write their answer in interval notation is they use the wrong symbol, either a square bracket instead of a parenthesis or vice versa. So just be careful with that. All right. Now, I said earlier that there's a situation that's going to occur which would result in, as you go across your line, that the signs are not going to alternate. So I'm going to do an example, and I'm going to tell you exactly when to look for that. So here's the example. Here's the problem. What your eye needs to see is this x squared. That's what you need to see. This is going to be the situation where there's an exception to the rule that the signs alternate from interval to interval. And here's why. I'll explain very quickly. No matter what number you put in for x right there, whether it's positive or negative, when you square it, it's going to be positive. It's going to be positive. So when you cross over 0, so to speak, as you start putting values into this expression that change from being negative to being positive, x squared is going to always be positive, no matter what you put in. So let's make our sign line. And on my sign line, I'm going to put my critical values, which would be the values that would cause the expression to equal 0 and or be undefined. So this expression would equal 0 if I put in a 0. This expression would be undefined if I put 13 in for x. Now I'm just going to do what I've always done, but I'm going to go interval by interval as I pick a number, all right? Let's suppose I pick a number from this interval. And again, I'm going to pick -1,000,000. When you put negative 1,000,000 in for x in the numerator, you're going to get a positive result. When you put negative 1,000,000 in the bottom, you're going to get a negative. And a positive divided by a negative is negative. But look what happens when you pick a number between 0 and 13 from this middle interval. Let's pick 10. 10 squared would be positive 100. 10 minus 13 would be negative. So I'd have a positive divided by negative. It's still negative. So this is the one that I told you about, I forewarned you about, and I said you got to look for. What is the telltale sign? An x squared. Because when you square it, no matter what value you put in, it's always going to be positive. So look what happens. It's negative, and then the next interval, it's still negative. And then when you pick a number from over here, you'll have a positive over a positive, and it's going to be positive. Okay, so let's answer the question now. When is this thing negative? That's the question. When is it negative? Be careful. It's negative over here. From negative infinity to 0. But at 0, when x is 0, it's not negative. It's equal to 0. So you have to exclude 0 from your answer. You also have to exclude the number 13 because that causes the expression to be undefined. So the answer to this would be negative infinity to 0, parenthesis, union, parenthesis, 0. Doing that right there excludes the 0, and I'm going to go to 13 and put another parenthesis. Now, what if I did this? Watch. What if I changed the problem to x squared over x minus 13 is, let's say, greater than 0. Okay. We're going to look at the same sign line. We're looking at the same sign line for this problem. Looking at the same problem, but now, same sign line, but now we want to know when this thing is positive. Well, when is it positive? It's positive over here. So it would be positive from 13 to infinity. So I'm going to say parentheses 13 to infinity is going to be my solution. What if I do this? I have x squared over x minus 13 is greater than or equal to 0. Well, we know when it's greater than. We just did that. But we have to include this one point in our solution for this inequality. So I would say square bracket 0 to 0. That takes care of this one point right here in union with 13 to infinity. I could tell you it's not uncommon to get wrong answers for a problem like this because this part of the problem is kind of forgotten. That part of the answer is kind of forgotten. All right, let's go on. Look at this. What's the difference between this problem and all the other problems we've done? The difference is that this problem needs to be factored first. So that's the game plan. You factor and you make your sign line, and then you determine when the expression's positive or negative depending on what the problem asks you to do. I'm sure you recognize this as the difference of squares, which factors into its conjugates. Sign line time. Critical values would be -5 and +5. If I put a -5 in, I get a 0. If I put a +5 in, I get a 0. I'm going to pick a value from over here, like -1,000,000. This first quantity would be negative. The second quantity would be negative. So a negative times a negative is a positive. And then I'm just going to alternate negative, positive. And I want to know when it's less than or equal to 0. That would be on the sign line, this part of the sign line right here. And that transfers right over to interval notation from -5 to 5 with square brackets because it's or equal to 0. Look at this. This may look kind of like the same problem, but it's not. It's not the same problem at all. Now this expression, x squared minus 25, is in the denominator. Well, you guys know you cannot have an expression in the denominator that equals 0. So 5 can't be part of my answer, and neither can negative 5 be part of my answer. So this becomes this sign line, critical values negative 5 and 5. But instead of putting a 0 here like I did in the last problem, I'm going to put undefined. Now, if I pick a number from this interval on the far left, like negative 1,000,000, I'm going to have a negative times a negative, which is a positive. If I pick a number between negative 5 and 5, let's say 0, I'd have a positive and a negative. And if I pick a number from over here, I'd have a positive and a positive. I'm looking to see when this thing is positive, greater than or equal to 0. First of all, this right here, just look at it. This expression will never equal 0. In order for a fraction to equal 0, the top number has to be 0. We have 1 in our numerator, and it's never going to be 0. So 0, this thing can't equal 0, so it'll never equal 0. So the question is then, when is it greater than 0? And it's this interval here in union with this interval here that it's greater. So I'm going to have negative infinity to negative 5, parenthesis, union, parenthesis, 5 to infinity. All right. Another example. Game plan. You have to factor. You have to be good at factoring. So the first thing I'm going to do is take an x out. I'm going to change the problem a little bit. I factored out the common factor, which is x squared, which gives me x minus 19 inside the quantity, inside the parentheses. Look at, remember that? This guy over here? That x squared is going to cause a little different situation. So when I make my sign line, my critical values are going to be 0 and 19. If I put a 0 in for x, this thing equals 0. If I put a 19 in for x, this thing equals 0. If I pick a value from over here, like negative 1,000,000, x squared, when you square negative 1,000,000, it's positive. And then negative 1,000,000 minus 19 is negative. So it's going to be negative. If I pick a number between 0 and 19, let's say 4, this would be positive, x squared, but this would be negative. So it's still going to be negative, and then this will be positive. And I want to know when it's going to be less than 0. So that's going to be this interval here, and I have to exclude 0, and this interval here. I have to exclude 19. So in interval notation, it would be negative infinity to 0 in union with 0 to 19. Not too many more. I could tell that you're getting a little tired of hearing this. Let me do one more problem for you. Okay, look at this. Name it a game. You have to factor and then make your sign line. When you look at these three terms, you'll notice there's an x, a common factor of x. Then you're going to factor this trinomial into two binomials. Multiply to give you negative 14, add to give you 5, so it's going to probably be a positive 7 and a negative 2. Make your sign line. You're going to have a negative 7, you're going to have 0, and you're going to have a positive 2. Any of those values is going to cause this expression to equal 0. If I pick a value from the far left interval, like negative 1,000,000, I'd have a negative times a negative times a negative, which is negative, and then these will alternate. And I want to know when it's greater than or equal to 0. So that's going to be this interval here, from negative 7 to 0, including the endpoints, in union with 2 to infinity. So in interval notation, square bracket, negative 7 to 0, square bracket, in union with square bracket 2 to infinity. All right. Now, I'm not going to do any more problems for you, but I just want to run back through with you what we did. Our objective was to learn how to solve inequalities using a sign line. So I'm hopeful everybody can do that now. You can make up your own problems and give it a shot, but I'll have some for you, and I'm sure that you would plan on that. All this was right here, this whole part right here, was me re-explaining to you or reviewing with you how to do interval notation and how to solve first degree inequalities. And if you recall, I wanted to really emphasize to you that when you divide by this negative, you have to reverse the inequality. Don't forget to do that. Then I just use the x squared to start talking about some second degree situations. Sometimes your answer would be all real numbers, and sometimes it's empty set. Just remember, when you square something, it has to be positive. Here I introduced the sign line, and I defined for you what I mean when I throw around the term critical values. The values of x that cause the expression to equal 0 or be undefined. And most of the time just a couple, but there could be an unlimited number of those. And then I did some examples. One thing to point out is any value that would cause a denominator to equal 0 cannot be part of your answer, no matter what. All right. This was a special situation involving the x squared. The x squared makes it so you do not alternate as you go from interval to interval insofar as the sign of your solution. All right. And then we got to this problem, and this was the first problem, this x squared minus 25, where I made the point to you that most of the time when you solve these problems, you're going to have to factor first. So first you factor, and then you make your sign line, and then you go from there. The last thing I'd just like to mention to you, and this will just be real quick, and I'm not trying to teach you this. What I'm trying to do is I'm trying to give you a reason for knowing how to do this. This skill, the sign line skill, is a very important skill to have when you arrive on the first day in your calculus class. So those of you who are juniors, who are going to end up with Mrs. Ford next year, she's going to expect that you know what a sign line is and how to use it. And when you get to college and you take your calculus class there, those of you who are seniors, you're going to need to know how to do this. And the reason you need to know how to do this, and I'll try to make this really, really quick, is it's important to know when an expression is positive and when it's negative. It's important to do that for there's some really good reasons for that. You guys know that this is the equation for a line, and this value right here is the slope. When you get to calculus, what's going to happen is you're going to have an expression that's equal to that value. You're going to have an expression that's equal to that value. It could be an expression like one of these expressions, like maybe this even. You can have an expression like this, the x cubed plus 5x squared minus 14x, that would be equal to whatever that slope is. And you would want to know when that expression is positive and when that expression is negative. Because if the slope is positive, that corresponds to having an increasing relationship. And when the slope is negative, that corresponds to having a decreasing relationship. So the point is, in a nutshell, by being able to use the sign line tool, you can determine when an expression is positive and when it's negative. And that could tell you when something is increasing and when something is decreasing. And I know you don't fully understand everything I just said, and I don't want to go into the details, but I just wanted to let you know you're not just doing this for no reason at all. There's a good reason. All right. Hey, thanks for your attention, gang. I hope this has been helpful to you. Thanks for listening. And be looking for some problems coming your way.